Free response question number 1. Evaluate each limit below analytically. There are 3 limits which we will take a look at. The limit as h approaches 0 of the square root of 4 plus h minus 2 divided by h. Letter B, the limit as h approaches 0 of the 4th root of x plus h minus the 4th root of x divided by h. And letter C, the limit as h goes to 0 of the cosine of x plus h minus the cosine of x divided by h. You'll notice I highlighted h approaching 0 in all 3 cases. We are going to differentiate each one with respect to h, and that's going to affect how we evaluate our limits. The upcoming examples will show you exactly how that comes into play. Free response question number 1, part A. We're going to evaluate the limit as h approaches 0 of the square root of 4 plus h minus 2 over h. First of all, let's replace h with 0 to see if we have an indeterminate form. So 4 plus 0 is 4. The square root of 4 would be 2. 2 minus 2 is 0. And the bottom is 0, so we do have an indeterminate form of 0 over 0. Since that's the case, we can take the derivative of the numerator and the denominator because of L'Hopital's rule. The limit as h approaches 0 of the derivative of both the numerator and the denominator will be the same as the original function. Also note that we are going to differentiate according to h. So I'm going to make this a little bigger so it's easy to see. The limit as h approaches 0 will be the derivative of the numerator using the chain rule, 1/2 4 plus h to the negative 1/2 power. The derivative of 2 is 0, and on the bottom the derivative of h is 1. Cleaning this up, we're going to rewrite this as the limit as h approaches 0 of 1 over 2 times the square root of 4 plus h. I replace h with 0, and that gives me 1 over 2 times the square root of 4 plus 0, which simplifies to 1/4. So, as h approaches 0, the square root of 4 plus h minus 2 over h approaches 1/4. Free response question number 1 continued. This time we're looking at part B. It's the limit as h approaches 0 of the 4th root of the quantity x plus h minus the 4th root of x divided by h. Let's see what happens as h does approach 0. As h approaches 0, we have x plus h becomes x, so we have the 4th root of x here, minus the 4th root of x, which will be 0. And since h is 0 here, we'll have an indeterminate form of 0 over 0. So we can use L'Hopital's rule. Now, before we differentiate, I'm going to rewrite this expression as the limit as h approaches 0 of x plus h raised to the 1/4 power minus x raised to the 1/4 power divided by h. Also, remember, we're looking at the limit as h approaches 0, which means we are going to take our derivative with respect to h, treating x as a constant. So with that being said, the derivative of the top using the chain rule will be 1/4 x plus h raised to the negative 3/4 power. The derivative of x to the 4th power, we treat it as a constant since we're differentiating with respect to h. That'll become 0. The derivative of h is 1. Let's clean this up a little bit. So as we simplify and get rid of our negative exponents, we're going to have the limit as h approaches 0 of 1 over 4 times the 4th root of x plus h raised to the 3rd power. And as h approaches 0, we're going to be left with 1 over 4 times the 4th root of x raised to the 3rd power. So what happens here is that depending on the value of x, the limit as h approaches 0 will be this. As x gets bigger, the value gets smaller, approaching 0. As x gets smaller, we approach infinity. Free response question number 1 continued. This time we're looking at part C, and it's the limit as h approaches 0 of the cosine of x plus h minus the cosine of x divided by h. Let's see what happens if we replace h with 0. So, replacing h with 0 gives us x plus 0 is x, so we have the cosine of x minus the cosine of x divided by h. Cosine minus cosine is 0, and as h approaches 0, we have 0 here, which is an indeterminate form, 0 over 0. So we can go ahead and use L'Hopital's rule and differentiate the top. So the derivative of cosine is minus the sine. The derivative of x plus h with respect to h will be 1. So that's where we get this 1 here. Our cosine here, cosine of x, we're going to treat that as a constant since we're differentiating with respect to h. That's why we have a 0 here. And then the derivative of h becomes 1. And now we're going to clean this up. So instead of having negative 1 times the sine of x plus h minus 0 over 1, it's going to look like the limit as h approaches 0 of minus the sine of x plus h. So we replace h with 0, and we end up with the limit will approach negative sine x. So the limit will depend on the value of x.